Okay, this is the notes for section 4.7, isometries. At the end of lesson 4.6, one of the things that we did is we kind of summarized the transformations that we've looked at so far: reflections, rotations, and translations. Well, all three of those transformations fall under a larger category, which we're going to call isometries. Okay, and all an isometry is a transformation that is a reflection or composite of reflections. Okay, these are also called congruence transformations, and we'll talk about congruence a little bit later on. Okay, so far we've looked at reflections over one line. We found that the only possibility would be a reflection. We looked at reflections over two lines. Well, there's two possibilities. The lines could either be parallel to each other, in which case we have a translation, or they could be intersecting, in which case we had rotations. Well, what happens then if we look at three reflections over three lines? Well, those lines could either intersect in 0 places, 1 place, 2 place, or 3 points. Those are my four possibilities that could actually occur. Now, if we perform three reflections over three lines that intersect in 0 points or 1 point, the result is exactly the same as if I had done one reflection over one line. So we don't get anything new out of that. There's no new type of transformation that actually occurs. However, if we perform reflections over three reflections over three lines that intersect in 2 or 3 points, we get a new isometry. And we can call that isometry, or we're going to call that isometry, a glide reflection. Okay? Now here's how we're going to define a glide reflection. A glide reflection is just going to be a reflection followed by a translation in the direction parallel to the reflection line. A glide reflection is generally going to be referred to as a walk because it looks like we're walking along a line. Now, we said there was three reflections. Remember, one of those reflections comes here, obviously, from a reflection. But remember that a translation is two reflections. So if I add those two things together, there's actually a total of three reflections that occur in a glide reflection. Okay? So this is an example of a glide reflection down here. The foot has been reflected to get this foot, and then it's been translated using this vector to get the final image. So this is my pre-image, and this is my image. This is the work to help me get there. Okay? Because a glide reflection can be thought of as three reflections, they also preserve angle measure, betweenness, collinearity, and distance. All those things that have been preserved in all reflections, but just like reflections, orientation is reversed. So earlier we talked about the fact that isometries are reflections and composite reflections, and we said that reflections, translations, and rotations, all three of those were isometries. Well, after now defining what a glide reflection is, since that is a composite of three reflections, that would also have to be an isometry. And in fact, it's our fourth and final isometry. Any other set of reflections can always be boiled down to one of these four isometries. So no matter how many reflections we do, it's going to turn out we can simplify it down to either one reflection, a rotation, a translation, or a glide reflection. Okay? So one of the things that we're going to need to be able to do is, if we're given an image and a pre-image, we want to be able to determine which of the isometries has been performed on it. Okay? To help us do that, I have a chart here to kind of help us. So we have isometries. There's two types of isometries that we're going to look at: orientation preserving and orientation switching. So if it preserves orientation, it would be the ones with two reflections, which are translations and rotations. If it switches orientation, it's going to be either a reflection or a glide reflection. You'll notice that the identity transformation is underneath orientation preserving. An identity transformation is just something that gets a figure right back to where it started. So we want to use that in helping to do the next example problem. Alright, let's take a look at example 1 here. It says identify the isometry that maps one image onto the other. Well, to help me do that, what I'm going to first try and do is I'm going to try and figure out, do I have something that's orientation preserving, or is orientation reversed or switched? Okay. Well, if I look at this figure right here, if I were to go around kind of, looking at these corner points, starting in this corner, going around, I'm going around in this direction, that would be a clockwise turn. However, if I look at the exact same points in the exact same order down here, I'm going around in this direction, which is the opposite of that, which would be a counterclockwise turn. So what that tells me is that it must be an orientation switching or orientation reversing isometry. So it's either got to be a reflection or a glide reflection. Well, reflections are pretty easy to see because it would have to come right down in this area. So it looks like it's come down in this area and it's been moved over in this direction. Therefore, this would have to be a glide reflection. Okay? On the second one, if I look at the orientation on those same points, I'm going clockwise here and I'm going clockwise here. So I know it's got to be either a translation or a rotation because it's orientation preserving. And since I didn't turn at all, it just slid down the page, it would be a translation. Okay, let's take a look at example 2. It says draw G, which is a glide reflection, of triangle XYZ, where G is a translation followed by a reflection over line A, and the translation is determined by vector V. Okay, so you have the same drawing in your notes. I've just had to place it in a separate place. So I have some room to do some work here. So what I'm going to do is I'm going to start by taking that figure and I'm going to perform the reflection first. So I'm going to line up my ruler and I'm going to reflect each of these points in the same way that I did before. So I'm going to take a look at Z. I've got it lined up with my 90-degree here. Looks like I'm about 2.5 in. So about right in that range right there. So that's going to be my new Z prime point. Okay, I'm going to do the same thing now with each of the other points. You might want to do that as well at this time. Okay, so I've completed reflecting each of those points, and then I connected them to get my new triangle. Now I'm going to take that triangle and I'm going to slide it up the page the length of this vector. Well, as I look at this vector, my vector is almost exactly 3 centimeters, it looks like. So what that means is that I want to take each of these points and move it, and it's going to move parallel to this line, okay? Because this vector is parallel to this line, and we know for glide reflection that's always true. So I'm going to move it exactly 3 centimeters in that direction. So for each one of these points, I'm going to measure 3 centimeters to get it. So we'll start with Z prime and move that 3 centimeters first. Okay, so I've got my ruler then on Z prime. I'm going to measure up 3 centimeters to where that is, and I'm going to make a mark. That's going to be my new image point Z double prime. Okay, and then I'm going to repeat the process for each of the other 2 points. So I'm measuring up 3 here. This would be my new Y double prime. I'm going to do the same thing now with X, and I can measure up once again the 3 centimeters, and we'll plot that point. That would be my X double prime. Then I'm going to reconnect those points to get my final image figure. So this then would be the final, once I've reconnected the points, that would be our final image after that glide Okay, let's take a look at this final example then. It says triangle D prime, E prime, F prime is the image of DEF under a glide reflection. Using line N as the line of reflection, draw a translation vector. Okay, so what that tells us is that we started with DEF, so that's going to be my pre-image. We got D prime, E prime, F prime, that's my image. Okay, and this right here, this line, line N, is our line of reflection. Okay, so the easiest way that we can get that translation vector is I just need to find out at least where one point from this figure ends up after a reflection. And once I do that, then I can draw in the vector from that point to where the point ended up. So what I'm going to do is I'm going to take point D and I'm going to reflect it over the line. When I do that, I'll get an image point of D that I can then translate to D prime. Okay, so here's where D prime would be then if I do that reflection right about here. And then I'm going to use that to get my translation. So to finish that off then, I'm just going to draw the vector going from this image of D after the reflection up to where it ends up. And you'll notice how this vector is parallel to the line of reflection, which it should be. So this would be my vector for that translation. Call it V. Okay?